Okay, let's unpack this. Imagine you're a soccer coach, right? You're constantly striving to get the absolute peak performance from every single player on your team. And you've probably always drilled your defenders a certain way, your midfielders another, sort of based on their traditional roles. But what if that deeply ingrained traditional approach is actually, holding your team back from its true potential?
It's a fascinating question, isn't it? Almost subversive in a way. It challenges practices that are, well, decades old. Today, we're going to dive into some really cutting-edge research. It leverages the power of data and artificial intelligence to fundamentally redefine how we understand player performance right there on the field.
Yeah, exactly. Our deep dive today takes us into an article titled Beyond Playing Positions, Categorizing Soccer Players Based on Match-Specific Running Performance Using Machine Learning. This is some groundbreaking stuff. The study was led by Michel Haan and his team. It was published in the Journal of Sports Science and Medicine. That's volume 24, pages 565 to 577. Just for reference, it was received June 26, 2024, accepted June 27, 2025, and published online September 1, 2025. The DOI is available too. We'll link that. Our mission today is really to pull out the most important insights from this research, give you a kind of shortcut to understanding why just using those old player categories might be suboptimal. And more importantly, how these new scientific methods can lead to, well, significantly more effective training and performance evaluation.
And what's really intriguing here, I think, is how the researchers directly compared the long-standing practice, just categorizing players by position, against a completely data-driven approach using unsupervised machine learning. They asked a really critical question. Which method actually identifies groups of players with genuinely similar physical demands during a match? And maybe more importantly, what does this actually mean for optimizing training programs, specifically for young elite male soccer players?
Exactly. Think about it. We all intuitively group players, right? Forwards, midfielders, defenders. Seems logical. But the core question this study digs into is whether those tactical labels truly reflect the unique physical demands placed on players. Or, are they maybe masking important individual differences? This study gives us a scientifically clear, pretty accessible, and objective look at that exact question. So to start off, the researchers gathered a whole lot of match-specific running data. This was from 40 young elite male soccer players over 2 full seasons. These were U18 and U21 players from a professional club, so high-level talent. And they started by grouping these players using the traditional labels. Forwards, attacking midfielders, defending midfielders, fullbacks, and central defenders. And their initial finding, which, well, maybe isn't super surprising, was that, yes, match-specific running performance did differ between these traditional playing positions.
That's right. Yeah, that part makes sense on the surface. For example, central defenders consistently covered significantly less distance at high intensity or sprinting compared to, say, fullbacks. Fullbacks were almost sprinting the most, while central defenders sprinted the least among all positional groups. Forwards, too, showed different patterns. They covered greater sprint distances, but shorter overall distances at low and moderate intensities compared to defending midfielders. So yeah, on the surface, traditional roles seem to correlate reasonably well with physical output.
Okay, so it sounds like the traditional grouping is working just fine, right? Different positions, different running demands. Makes sense. But here's where it gets really interesting and makes you think a bit harder. Despite those clear differences between positions, the study uncovered considerable inter-individual variation, meaning, individual differences within those traditional positional groups.
Right. And that immediately raises a crucial question. If there's so much variation within, say, the group labeled defenders, how effective can a single generalized training program for that entire positional group really be? To give you a sense of this variability, the average coefficient of variation for high-intensity running within positional groups was 13.6%. Now, coefficient of variation is just a statistical way of measuring how spread out individual data points are from the average. So in practical terms, it means there was a pretty significant range, nearly 14% difference in high-intensity running, even among players assigned to the exact same position. This variability suggests that simply labeling someone a defender doesn't really capture their unique physical contributions or their needs.
Okay, that's a key point.
And maybe the most surprising finding in this part of the study, while playing positions showed differences in actual match-specific running, the study found no significant differences in average 20-meter sprint speed or maximal oxygen uptake, VO2 max, between playing positions.
Wait, hang on. So a central defender's basic sprint capacity, or their overall aerobic endurance, their VO2 max, which is essentially how efficiently their body uses oxygen during exercise, that could be fundamentally similar to a forward's, even if they run differently in a game.
Exactly.
Wow. That's a significant insight. It really challenges the assumption that different positions inherently demand different fundamental physical capacities.
It does, and the study points out that even those broader classifications like forwards, midfielders, and defenders are probably suboptimal because they lump together really important distinctions, like the ones between central defenders and fullbacks, or attacking versus defending midfielders.
Right. Okay. That makes sense.
So, this substantial internal variation, plus the lack of difference in fundamental capacities like sprint speed or VO2 max between positions, it strongly suggests that playing position alone probably isn't the best way to group players for physical training. And that brings us to the study's really innovative alternative, using unsupervised machine learning, specifically a technique called k-means clustering. Unsupervised here just means the algorithm looks for natural patterns and groupings in the data itself without being told beforehand what the categories should be. In this case, it grouped players purely based on the similarities in their actual match-specific running performance.
Okay, so letting the data itself create the groups, and the results from this machine learning approach were, what, pretty compelling. What kind of distinct clusters emerged?
Yeah, they were quite compelling. They identified 5 distinct clusters based purely on running performance during matches. There was a low-intensity endurance group, a high-intensity endurance group, a sprint group, a low sprint and endurance group, and sort of a balanced group. What really stood out was how much more distinct and uniform these machine learning-derived clusters were compared to the traditional positional groupings. The clustering method resulted in significantly less variance within these new groups, and much larger standardized differences between the groups across various running intensities, total distance, low, moderate, high-intensity running, sprint distance, all of it.
So the groups were tighter internally and more different from each other.
Precisely. For instance, the effect sizes, which basically tell us the magnitude of the difference between groups, were approximately twice as large for the clustering method compared to grouping by traditional position. That really indicates that these clusters truly captured groups of players with very, very similar physical outputs during matches.
And remember that earlier point about how there were no significant sprint capacity differences between playing positions?
Yes.
This is where the machine learning really shines, isn't it? When players were grouped by these performance clusters, they found a significant difference. The sprint cluster was, on average, about 1.5 kilometers per hour faster in a 20-meter sprint than the high-intensity endurance cluster.
That's a critical finding because it means the machine learning approach actually revealed underlying physical differences. Differences that the traditional positional analysis completely missed or sort of obscured. And this finding has pretty profound implications for training methodology, you'd imagine. Instead of a general training plan for all midfielders, coaches could now tailor, say, explosive power training specifically for players identified as being in that sprint group, regardless of their nominal playing position on the team sheet. Or, conversely, they could focus on targeted endurance development for players clustered in the high-intensity endurance group. This really allows for truly personalized and, you'd hope, more effective training programs that align precisely with a player's actual physical demands and capabilities on the field, not just their assigned tactical role.
Of course, the study does acknowledge some limitations, which is good science. It focused on youth players, and performance can obviously be influenced by things like strategy or the coach's philosophy, not just physical capacity alone. Also, the specific clusters generated are unique to this particular group of players. You'd need to run a new analysis for a different team or league.
True. But the core finding that traditional positional grouping is suboptimal for evaluating match performance and guiding physical training, that seems robust and broadly applicable.
So let's bring it all together. What does this all mean for you listening? This deep dive into beyond playing positions truly highlights, I think, a potential paradigm shift in athletic training. We've seen how, despite traditional playing positions showing some differences in match-specific running, there's actually considerable individual variation within those positional groups. And this fundamental mismatch makes grouping players simply by forward, midfielder, or defender a less effective, maybe suboptimal approach for physical training and performance evaluation.
Yeah, and this raises a really important question for coaches, trainers, even the athletes themselves. If playing positions aren't the most effective grouping, what is? The research convincingly demonstrates that using unsupervised machine learning, specifically that means clustering based on map-specific running performance, it creates more distinct and uniform subgroups. These clusters, like the sprint group or the high-intensity endurance group, they better reflect the actual physical demands players experience, and, crucially, they even revealed those critical differences in sprint capacity that traditional positional analysis completely overlooked.
And here's why this is so powerful, why it matters. It's not just some academic theory. For coaches and trainers on the ground, this means moving beyond a maybe too simplistic one-size-fits-all approach for a given position. It means having a more nuanced understanding of each player's unique physical profile based on hard, objective data. Imagine tailoring explosive power training specifically for those in the sprint cluster, or focusing on endurance development for players in the high-intensity endurance group, regardless of their official position on paper. That's how you truly optimize individual potential and potentially enhance overall team performance.
Absolutely. And this approach really encourages critical thinking about how we categorize athletes in any sport, not just soccer. It implies that understanding the actual work performed, what players are really doing out there through objective data, rather than just relying on historical or tactical labels, that could unlock entirely new levels of performance optimization and maybe even help with injury prevention strategies.
Couldn't agree more. This deep dive should definitely leave you with a lot to consider about the future of athletic training. If you're as intrigued as we are by these findings and want to explore the full methodology and all the data, we highly encourage you to read the complete article yourself. You can find all the details we discussed, the authors, the journal, Journal of Sports Science and Medicine, and that DOI link, https://diap.org 10.52082 JSM 20U25.565 in our show notes.
And remember, for more insights like this, breaking down the latest research, make sure to follow our channel and turn on notifications. We'll keep bringing you the most important nuggets of knowledge from the cutting edge of sports science.